Good afternoon, everyone, and welcome to today's webinar, Exploratory Data Analysis and Predictive Modeling. Just a short introduction of the JMP team. Today, I'm the host of this webinar. My name is Paolo Chiappa, and I am the Academic Client Manager for JMP. And today's presenter is Volker Kraft, who is Academic Ambassador Europe for JMP. As you can see, the audio lines are muted during the webcast. For any question, you can use the chat window in the upper menu and address the host. That is me, Paolo Chiappa. Before passing the ball to Volker, I just want to spend a couple of words because I think that maybe some of you are wondering why we decided to set up this webinar and let's say offer it to the academics at the University of Strathclyde. Well, it's not a secret that the University of Strathclyde is one of the top universities in the world, and more specifically, it's a leading technology school. Students learn how to improve and innovate areas like health, manufacturing, or energy, chemistry, robotics, and so on. Our mission in the academic team of JMP is quite simple and goes, let's say, in the same direction. We provide tools that help students, teachers, and also researchers to lead the innovation in those fields. And since data are already, and of course will be more and more an integral part of any academic and industrial context, we do believe that top universities like Strathclyde, of course, should be the first to introduce and nurture an analytical culture. So, Volker, I will now pass you the ball. Here we go. And I will mute myself for the moment, okay?
Thank you, Paolo. I hope you can see my screen, and welcome everybody.
Yeah, perfect.
Thanks for your time and your interest in JMP. And as Paolo said, I'm also with the JMP academic team. I'm based in Germany, and I have the pleasure to show you what JMP is about and to give you maybe a first idea about JMP and what makes it really unique, especially for academic use. So that's the goal today. And I don't want to spend many words about it and talk about it. Rather, I would like to show you JMP live with some examples. So I will skip the introduction today and let me introduce you JMP very briefly, and then we will come to some demos later on. And I would really like to show you how to explore data. So if you get a new data set, how to explore a new data set, how to get an idea about patterns and relationships in your data, maybe also about problems with outliers, missing data, and so on. And then how to get a first idea how to learn from your data, how to build models. And that's the main focus today, exploratory data analysis and predictive modeling. We will also briefly touch some resources we have online for learning and teaching with JMP. And we will also look at some next steps and what could you do to dive deeper and learn more after this maybe teaser like first demo. So what is JMP about? It's quite old. The first version came out in 1989, and it's really unique and different also compared to many other packages, analytical packages. I think it's more interactive, it's more visual, and it's also more intuitive and easy to use. And that's the main reason for many people to use JMP, also in teaching settings. But it's also used, especially by many researchers, together with other packages. So you can integrate JMP with R and Python and MATLAB, Excel. You can also open other data sets like an SPSS or Minitab or other data sets. So JMP is also really open and extensible. It also comes with its own scripting language called JSL, JMP scripting language. so to build your own applications. But what you will see today is just drag and drop, point and click. So the easy way, the most accessible way using JMP to learn from your data. So I don't want to look at all these links here. So on the right in my browser, you see some some customer stories. So that's maybe a good starting point to see how is JMP used in industry and by other academic users. But I would like to give you an overview about the application areas in JMP. So how can JMP be used? What are the typical use cases? And here we have 6 of these broader application areas. And today we will look into data visualization, exploratory analysis, and into predictive modeling. So these 2. And you can go here also on our website and then click on such an area, and then you get access to white papers, use cases, and some demos. So there are also other areas to use JMP: application building, market research, and consumer research. Then Six Sigma, quality and process tools. And on the upper left, so we have DOE, design of experiments. Unfortunately, we won't have the time to look into this topic today, but that's definitely one of the core application areas in JMP, and JMP is probably a leading toolset for statistically designed experiments, and not just for the design, but you also get all the analysis tools in the same package. So DOE is definitely a hot topic, and if you look at JMP, so you can check the DOE menu, and as I said, we won't have time to cover this today, but I really encourage you to have a look at some demos or webinars we have online if you're interested in experimentation. So that's definitely an interesting topic. Just 2 highlights: custom designer, you an optimal design created by the computer, giving you the highest flexibility you could get to really define your problem and get a design specifically for your problem. So a tailored design for your problem. And then there are also there are classical traditional designs, but the second highlight is definitely the definitive screening design, a quite modern method, so which enables you to learn from data, learn about data, screening data very efficiently, and you get a lot of information, and you can really reduce uncertainty, for instance, about confounding and so on. So you learn a lot at a low budget. So that's really an exciting and amazing, more modern method for DOE. So these are the application areas, and the second link I would like to point you to, so if you look at JMP in action and then academic, you get to our academic webpage, and if you scroll down, you get a portal with resources for learning and using JMP, also with teaching material. So if you look at the webinars on the left, or learning library, case study library, so these are definitely very nice starting points to learn more and to dig deeper. Yeah, so it's very easy to get a JMP license to play with. Just use jmp.com/try, and there you can get a 30 days trial license for JMP. If you want to try JMP Pro, which is included in an academic side license, just get in touch and we will get you a JMP Pro trial license. So that's just to set the stage. So now let's have a look at JMP and what this is about, and what's really special about JMP also compared to other software you probably know about. And today I would like to look at two data sets basically. The first one is about birth and death rates for different countries, and that's basically to explore a new data set. And then the second one is about customer churn, and this one will be also used to build some predictive models. So let me open the first one, and by the way, both of them are coming with a sample data sets in JMP. So if you get a JMP trial license, you also get 500 sample data sets, including these two. So if this is the first JMP data set you see, so here we have 4 different variables in 4 columns. And you also see the columns here. So we have country, birth and death rate, and region. And if you look at the columns panel on the left, you see that we have different types of variables. So region and country, so these are labels, names. So these are configured as nominal, which means categorical data. The other two, birth and death rates, so they have numeric data, and they are configured as continuous variables. So the values are on a continuous scale, which means you can calculate means, and you can calculate a sum, and you can use the values for calculations and analytics. So 4 variables, 2 different types, and we have 74 rows, and these are the countries. So these are the first 6, Afghanistan, Algeria, and so on. And for all countries, we have the birth and death rate, and also the region the country belongs to. So let me start to explore this new data set. And as soon as the data is ready in JMP, ready for your analysis and statistical discoveries, you basically go to one of these menus. And the Analyze menu gives you access to analysis tools, and there we have distribution. So that's for univariate analysis, fit y by x, 2 variables, a relationship between a y and an x. So this is about bivariate statistics. And then you have multivariate methods, including fit model and predictive modeling tools like neural networks, tree-based methods, and other specialized and multivariate methods as well. So they are more analytic. On the graph menu, you find platforms which are more visual and creating graphs, but you also get statistics. On the Analyze menu, you also get visuals, so it's not that black-white, but it's a different perspective you are coming from. And here we have the Graph Builder, a tool we will look at in a few minutes, and also some other probably known graph types. So let me use the first one, Analyze and Distribution. So I get the launch window, I select all my variables, I want to analyze all of them, so I assign them into roles, and then I confirm with OK. So now we get bar charts for country and also for region, and we get histograms and a box plot for our numerical data for birth and death rates. So for the country, we see every country is represented once. So this is not informative. Let me remove that one. So now we only have the birth and death rates and the region. What's specific and special in JMP is that such an output, such a report is not the end. It's not your final result. So this is more a starting point to dig deeper, to learn more, to run some tests if you're interested in hypothesis testing, for instance. So, and for that you get context menus, and you get more options on red triangles, which are the context menus in JMP. And here, for instance, I could add a normal quantile plot if you're interested in normality. I could also fit a continuous distribution, any specific distribution, or ask JMP to find the best one. Log normal, maybe I expected normal, so I can compare both of them. So the green one is the best according to JMP, and the normal is the one I maybe expected, so I want to compare with. And then I can dig deeper. So if I'm interested in the goodness of fit, for the normal fit, I can run a goodness of fit test. And then JMP knows which test statistic to use to answer that question. And here we see a p-value. It's colored. It's orange, which means highly significant. And you can also read this saying small p-values reject the null hypothesis, which is the data are from a normal distribution. So they are probably not. So I remove this again. And we also see that we have outliers here. So if you look at the box plot, so we see there are 3 extreme values which are maybe outliers, and I can point to such a data point. We see the row number. Maybe it's a good idea to use a variable we have for labeling our data. So I right click and then pointing to that data point again, we see this is Angola, and we also see the other two countries here. So the second one is Mozambique, and the third is Afghanistan. Now I can also select them here, and we see immediately that these 3 are in these 2 regions, Africa and Asia. And after selecting them on a report, we also see them selected as rows in our underlying data table. It's all connected in JMP. That's another unique feature. So if I click Europe, we see the birth and death rates in Europe and can directly compare them to Africa. And you see that Africa has really high birth rates compared to Europe. I can also select the data with higher death rates, and if I deselect my columns, you also see these selections in the underlying data table and in all other open windows. And by selecting the higher death rate countries, we see that regarding birth rates, we have 2 clusters here. And we also see that these are in 3 different regions, Europe, Asia, and Africa. So that's the distribution output, which gives you an idea about this dynamic linking. So everything is connected in JMP, which makes data exploration really easy and fun, and you can see relationships directly. So the next step, let me do this briefly, bivariate analysis. So now I look at the death rates by death rate as my Y, by birth rate as my X. So this will be a scatter plot. It's continuous versus continuous. If I also look at continuous versus categorical using the region, so we will get to a one-way ANOVA. output. So this is an example that the modeling types of your variables really matter in JMP, because using the same tool or platform, you get different results. And not just the first result, you also get different options on the context menus. So there are different things to do next according to the analysis context. And the context on the left, so that's a scatter plot. And here I can fit a line, and I can do things like adding a bivariate density ellipse. If I go down, we can also see the data here. We see the correlation coefficient down here. I can try another fit. So this is basically about fitting. So I can fit a quadratic curve, and we get the blue one. And we see all the details down here. On the right-hand side, so this is the continuous death rate by group, and the group is a region. And here the options are different. So this is more about means. So I can compare means. I get an ANOVA output. I can also compare the means. I select a method here, and then I can select the region. So now I selected Europe, and the only other group with a statistically significantly different mean is South America. So all others have the same color, so that tells me they are not statistically significantly different comparing the means. So this is just a part of what you can get from the bivariate analysis platform. And very briefly, Tabulate is a tool which allows you to create summary tables quite easily by drag and drop. So I want to have other statistics, not the sum. I want to see mean and standard deviation, break it down by region. And now I'm done. I could also add more. I could add the country here, but I could also maybe add the number of countries per region here. And when I'm done, I click done. I could also add a visual, but this is more about summary statistics in a table. And as soon as you have something interesting you would like to keep, you could always choose keep this, save it as a script, maybe to the data table. And then if you look at the upper left panel in my data table, you will see a new script added there, my tabulate, and now I'm done. So I can come back to this later or share this with a colleague, and then click on the green triangle and you get back to the same report where you can continue and change it. So it's the same interactive report again. That's Tabulate for summary tables. The other most important exploratory tool is the graph builder. And this is a drag and drop tool where you see your variables on the left and you get a palette on the right. And now I can drag and drop my variables. So if I take death rate and then I drop it on the y-axis, we see the death rate jittered on the x dimension, but we see all the death rates, and here we have Angola, so the extreme value again. If I add a birth rate on the x-axis, so we see that we get the same scatter plot again with a smoother line. I could also change by changing the lambda parameter and fit it more and more to the data available. But I can add more variables. So here we also have the region, and I could use the region to group this on different dimensions, or to wrap it, and then we get a grid with scatter plots per region, or I could overlay, so we get a smoother per region, or just color, so we get one smoother, but they are colored by region. So different ways to use other variables as well to break it down. Let me remove this again. So add variables and variables, there's no limitation there, except some visualization best practices, of course. But I can also choose other elements, for instance, the contour or the ellipse. Maybe I want to add the data as well. And I could also add a line here, so then I get a regression line. And I can also switch it off again. So if I click Start Over, so I could also take country, and there's a special zone here called Map Shape. Of course, JMP also comes with shape files, so I can drop the country variable there, and then we see a map with all countries. Let me add the missing countries as well. And now I can take the death rate and show death rate by country. And when I'm done, I click Done. And then again, I can point on a certain country. It's still dynamic, so I can select shapes, which are countries, just by multi-select. There's another way to visualize geographic data, so you can also have a background image, a bitmap, and now we have we see some water, so some blue. From the tools menu, I get the magnifier, so now I can zoom into Africa. It's a bit messy because some shapes are missing, so there we see the bitmap, and where we have data, we see the countries. So that's just to give you a first idea about some exploratory tools. So here's also another script. By the way, this is cluster analysis. So here you see a dendrogram, and we could change the number of clusters, so just one. And here we have 15 clusters. And now you see the countries clustered into groups by death and birth rate. And you see that Bulgaria and Russia go together, and Hungary, Romania go together, and Congo, Zaire, Ethiopia, and Uganda are grouped together. And by saving the colors, and so you can save the cluster IDs, but you can also save the cluster colors to your data table, and that's what was done already, and what's shown by the markers you see on the rows. Let me close this exploratory data set about birth and death rate and move on to another data set. So this is still no big data. It has a bit more than 4,000 rows, and each row is a customer record from a customer management system or customer database. And this is from a mobile provider, a telco provider. And the marketing department is interested in churn, the likelihood that a specific type of customer is going to churn, to leave the company and move on to a competitor. And for these 4,000 and a few customers, we already know if they churned or not. So target churn, this is our categorical response variable. We are interested in to explain, so to learn about what is related to churn, but we also want to predict the churn probability on new customer data later. So that's the second goal, to build a predictive model. So if you start to explore this data set, as I said, account ID, maybe this is not relevant at all, so I hide it from the data table. This is our response. And predictors, these are the other variables, so what we know about the customers. Account plan subtype, that's gold or silver customer. We know the age of the account. We know the state, so this is also in the US. So state is AL, Alabama, and others. The age of the mobile equipment, complaint code, which is the reason why they called the hotline the last time, if they had a billing problem or some call quality issues to complain about. Now, so these are our explanatory variables or predictor variables if you want to build a predictive model. Okay, so how to start? Maybe if you're in a marketing presentation, so you're interested in, so what about the different states, and what about the churn rates in the different states? And this script helps with that. So what happened here is that the script just created a summary table. So you could also do this manually, of course, by using that platform here. I just wanted to save some seconds, and I just run the script. So this gets a summary table with a row per state, and for every state we see the number of customers from that state and the number of customers who churned. And the ratio, that's the churn rate. And this is a formula. So here you see there's a plus, which tells you this is a formula column. And here we see the sum of target churn divided by the total number, so that's the churn rate. This is the formula editor, by the way, and you have many functions, especially statistical functions, but also conditional and logic functions to build any custom formulas you need. And with this summary table, I can now visualize what I was going to show. Maybe if I'm talking to marketing. So here's our churn rate by state. And you see that, it is different per state, and but state doesn't explain everything about the likelihood to churn. So we also have to look at some other customer characteristics and predictors and come up with a good predictive model. And that's what was already done in this data set. But let us go further. So if you start to explore the data, maybe what I do is I select all the customers who churned. So I deselect everything first, and now I take this cell here, churn, I right click, and then I select all matching cells. So by doing this, so 1,971 rows are selected now, and these are the churned customers. So that's an easy way to just select them, and we see these are the red ones, and the churned customers are still selected and also highlighted in the distribution outputs. So we can check the average calls per weekdays, but there's maybe no significant pattern we can see here. The same for account age, no pattern which can be seen easily. But if we look at average days delinquent, how many days are we waiting for the money after sending out the bill? We see that if this goes up, also the portion of churn customers really goes up. So here we see the highlighted subdata from the churned customers. Same here, complaint code. So we already see a relationship. So we see that if the complaint code was call quality, if that was the reason to call the hotline? Oh, there's a high likelihood that this customer is going to leave us. If the customer is telling us, oh, I'm going to move and I will have a new address next month, that's not a reason to churn, obviously. So you can already explore some relationships and make some discoveries just by looking at univariate output from the distribution platform, because everything is connected. You would also definitely take the graph builder and explore the data set further. And one example is this here. You could get from the graph builder bar charts to compare gold and silver customers, just to give you an idea about possible outputs. The parallel plot, so this is another graph element also provided in the graph builder. And here you can see the gold and silver customers separately, and so the silver customers are at the bottom. And we have an additional element on the left, which is a local data filter. And the local data filter can be used to select a subset of data by using complaint code right now. So I can only look at the customers with billing problems. I can only look at customers with call quality problems. Here we see a lot of red because call quality was a good reason to churn. And still, everything is connected. So I can just pick the upper customers, and you see the profiles of these silver customers also for other variables down here. So you learn step by step about your predictors, what are the hot predictors, really explaining something, what we see in our response. And then you start to build models. Yes. If you want to take the fast lane, so you could also ask JMP on the screening menu to do a predictor screening. So the question is, if you want to predict target churn, what are the best predictors? And all predictors are added as access here in my launch window, and then I click OK. And you get a ranking of your predictors. And this ranking confirms that the average days delinquent is really important. And also complaint code is really important. It also tells us that the condition of the current handset and some other variables down here are not important at all. So this is a very fast screening of your predictors. So if you want to do it more manually or using a specific modeling type, you could build a model maybe by taking the fit model platform. And what I do here is I set the response, or Y, and you see that JMP automatically switches to nominal logistic regression because the response is categorical. Other options are stepwise, generalized regression, and mixed models for continuous responses. And then I take all my predictors, so I'm still undecided and open to take all of them as model effects. And there's another role here in JMP Pro, which is validation. So this is for cross-validation. So to pick the best model which does the best prediction on new data in the future. So we don't want to build a very, very complex model using the data we have. We want to be really good on the data we don't have yet. And that's controlled by managed by cross-validation, and the data will be split into different sets, and some subsets will be put aside for validation and testing purposes, especially for model selection. And this can be done by using the subset variable, and the subset has been created for this, and as you see here, if you don't have this in your data set, so special predictive modeling and then make validation column, you have many options to define the subsets for training, validation, and testing, with fixed data or formulas or stratified random selection, so many options there. So here we use subset to do this, and I'm interested in churn. I want to model churn. So I set the target level and then run this script. Okay, so sorry, this is not a script yet. I just launched the platform manually, but there is also a script I could also run here by just clicking on this green triangle. So this was done manually, and we already got the model report. And again, we see the ranking of model effects. So the most significant one, according to p-value, is average days delinquent. And then the second place, complaint code. The third, the percent increase month on month. So how much is the revenue increasing on a monthly basis? So they seem to be important, and some others are not important at all. Sorry, I can just remove them interactively, and this corresponds to a backward stepwise regression. Start with a full model and then remove the least significant ones step by step. And maybe also take that one here, and I end up with this model here, and then we see the whole model test, so the model is significant, and we also see some metrics like R squared. The fit details, for instance, they show me maybe you want to look directly at the test data. So these data were not used build this model. So this is really an honest test of the model we have, built with the training data. And one common metric to look at is the misclassification rate. So using this model, we are wrong in 22% of the cases by predicting the churn. We can also look at the details using the confusion matrix. So here you see the details, and you see the correct ones on the diagonal, and you also see the errors, the confusions on the test data set, for instance. A lot of other information here, the fit details, lack of fit. You can look at the lift curve, which tells you how much is this model better for which portion of our data, of our customers. So how much is it better? How big is the lift comparing to just guessing? And here we see, there is a lift. So it's almost maybe twice as good for 20% of our data. So that's the lift curve. Let me switch it off again. But the most important tool to understand the model and to make decisions and to see how this works internally is to look at the profiler. And here we see our model effects. So these are the important predictors still in our model, the most significant ones, at certain settings, and the settings are the red values. So an equipment age of 11.9 and a percent increase MOM of 3%, and we have a gold customer and so on. And we see that our model predicts a churn rate of 61% for such a customer. And we see if the percent increase, if the revenue increase goes up, the churn rate goes down very quickly. Yeah, and if the percent increases about 80%, the account age is not important anymore. And also many other predictors are not important anymore. We also see that call quality and inaccurate sales information and the billing problem are really increasing the churn. Also, what we saw at the beginning about average days delinquent is that if this goes up, the churn rate immediately goes up. So this is a really steep curve. This is a highly significant effect for our response target churn. So this is the prediction profiler, which can be used to understand the model, which can be used to predict a response for a certain input or customer profile in this case, but it can also be used to compare different models and to see the differences and to understand your models better. And if you are happy with the model, if you want to keep it, you could go to the top red triangle and then save the probability formula. And this saves the formula for that model to your data table. And that was already done. So here for this logistic model, we see the formulas, and here you see how it was calculated. We see the formula in the formula editor, and then there are two probabilities, and the maximum wins. So if the maximum is no churn, so then the churn gets a 0, otherwise it gets a 1. And maybe I should also show you this here. So these are the data values in that column, but we have some labels. So a 0 is always shown as no churn, and a 1 is always shown as churn. But the data values in that column are really 0 and 1, but we have labels. That's just one example for column properties. So metadata you can add to your columns, to your variables. So the model is already saved, so we can add more customer profiles now, and then this column here would tell us, is this a customer type likely to churn or not to churn? Now, because there is a formula on that column. Another option is if you want to take this model and deploy it somewhere else, you can also publish the formula and then take it from here, from a formula depot, and then export it as C code, Python, JavaScript, or SQL code, and then deploy the model on other systems. So this was just one example using fit model on the Analyze menu to build a nominal logistic model. Of course, you have other options for modeling. Now, for instance, a decision tree. So here we see the starting point to build a tree. I can click Go because we have a validation column, a splitting column, and here we see how it works. So this splits the data and builds a decision tree like this we see here. And the question is when to stop growing the tree. And the answer is as soon as the red line doesn't improve anymore. And the red line, so that's the R square on the validation data set. So if the validation R square doesn't improve anymore, so then go back to the best R square we saw and take this model. And so here we see the number of splits. I think that's 18. And here we also see 18 splits were done. And according to our cross-validation, this is the best model to predict on new data. Again, we can look at a ranking, so which were the most important predictors used here, and we see our known candidates again, so average days delinquent, the percent increase, and complaint code, and so on. And of course, you can also look at a profiler, and you can save the prediction formula as well. And this was already done earlier. So here we have the formulas from the decision tree model. You can also build a forest with many trees, hundreds of thousands trees. And that's another way to build a model, especially if you have correlated predictors. So this is probably a good idea because it's more robust in the case of multicollinearity. And here we see only 29 trees were used. And again, you see a misclassification rate, which is about 19%, confusion matrix. And you can look at a profiler or save the prediction formula. Another option, number 4, neural network. Analyze predictive modeling neural. So if you use that one with a specific configuration, I think here we have 2 hidden layers. Yeah, so we have 2 hidden layers, and you can also have some boosting and really optimize the neural network. And what we got so far can be seen here. So we have a misclassification rate. I always look at the test data set. And there we see a misclassification rate about 23%. So you build a model, another model, and all models are wrong, but some are useful. So the goal is really to collect the most useful models. And then the question at the end is maybe which one to use if you have to pick one. And what helps here is a platform in predictive modeling, model comparison. So after collecting prediction columns in our data set here, so I can call this, and this compares all the models we built so far. And now I can sort this maybe by generalized R square. So we want to have the maximum here, and we see that the maximum R square can be found for the bootstrap forest model. So this uses all our data, more than 4,000 rows. If you want to do this just looking at a subset of data, maybe the test data. So I use the data filter. So I select test data only, and I say don't show the other ones, only show the test data, and only use the test data in calculations. So if I redo this again, so now we see that this only uses the test data, so a smaller subset. And when I choose to automatic recalculate, I can now switch to different data sets, and here you see that this report is now monitoring the underlying data, and if I change them by using the data filter, we see the results for specific subsets of data. So that's the end of the demonstration so far. Of course, there are many ways to build models. There are also even more ways to use JMP if you're interested in DOE or process and quality tools or marketing. So many other ways we didn't look into. And we also didn't look into setting up, getting the data ready, doing cleanup and preparation, sorting, structuring your data. So that typically takes a lot of time. Just a short message, all the tools for imputation and analyzing, managing outliers, maybe all these tools are also built into JMP and really make your life easier. And typically with all the visual outputs in JMP, you should directly see what's going on. And also if you have problems in your data set. So books with JMP. So there are many books you can also see online, and I had one special one, a recent book here I would really like to recommend. This is a new book. It's called Problem Solving for New Engineers. It's from this year, this summer, and this book is 80% about experimentation, and not the formulas, but why and how to do it. So this is really about the reasoning behind DOE, also introducing basic concepts like variability and bias and confounding and basic principles. But this is a great introduction, especially for engineers, about data science and experimentation. So next steps and why. The why is basically a summary. I hope you saw why to use JMP. Maybe also together with other packages like R. So you can still do something in R, but maybe you want to explore and tidy up your data first using an easier to use toolset in JMP. And then you can send the data from JMP to R, so there's an integration, an interface. And then you get the results back, and then you can use all the visual tools in JMP and tell the story behind your data and visualize the results. So if you think this sounds interesting to you, so what you could do is, and what we would suggest, get a JMP trial license, and you get there's a JMP, a standard JMP, 30-day trial at jmp.com/try. You can also get a JMP Pro trial version from us. Please get in touch. And what we saw today, predictive modeling, so more robust, more sophisticated methods are one advantage you get by JMP Pro. And then dive deeper, have a look at the sample data sets, check out the resources I showed you on the academic page, and maybe request a book. You can also get a free book for evaluation if you are interested. Just talk to us and we will help you out. And then we are happy to do any other follow-up session with you, maybe about another way to use JMP, maybe about DOE, design of experiments. So we saw that there are several people also interested in chemical engineering. So I would expect that this is a really hot topic there. If you have a specific course in mind where you would like to use JMP, we could also look into the topics and learning objectives, and then we can recommend some existing material, so you will never start on a green field there. If you have questions about licensing, so that should be the easy part, and just get in touch, send an email to Paolo, and we will suggest you the best way to get access to JMP. As I said, that's the easy part, And then, yeah, the fun part can start, and statistical discoveries much easier, much more fun, and also much better engaging students if you want to use it in a course than with any other software package I know about, at least. Okay, so far the demo for today. Thanks for your interest and your time, and please get back to us in case of any question. Thank you.